Good morning, ladies and gentlemen. I hope that you had a nice break and a happy Thanksgiving. I'm sorry I'm not there with all of you. Um, but before we get started today, I want to make sure that you have three papers you're going to need this morning. The first two are going to go with this first video that you're watching, and the last one will go with a second video. But you need to have all of those to get started this morning. And so the first one is the one that's right here on the screen called Newton's First Law of Motion Demos. And that is a paper that you received before vacation or should have. And we actually filled out the top together as well as a description of what happened in the pie plate egg drop. And then you were supposed to have written a description of what happened with the tablecloth pull using, of course, science vocabulary, a good scientific explanation using science vocabulary. And I listed some of the science words that should probably be included in your explanation. So we're going to actually focus in on the last part of that paper today, but you need that paper. You are also going to need, let me close that one. You're also going to need a paper that looks like this, and this should have been handed out to you already. If it was not, if the teacher would please pause the video and go ahead and hand that out. This is called Newton's First Law of Motion Review. We'll use that with this video also. And then the third paper that you are going to need, and that will be for the next video, um, is Newton's second law. And again, if you have not received that this morning, then if we could just make sure that that gets handed out before the next video, that would be great. All right. So, ladies and gentlemen, hopefully you have everything in order that you need. So, we're going to start by taking a look again at Newton's First Law of Motion Demos paper. So you should have written for the egg drop what happened in that particular instance. So we should have there that an unbalanced force was applied to the pie pan by, you probably have Sophia's name in there, Sophia's hand, and this caused the pie plate to move and apply an unbalanced force to the toilet paper roll. This caused it to move. The egg, however, has more inertia than the pie plate or paper roll, so it is not moved by the force applied to the pie plate. However, once there is no normal force supporting the egg, the unbalanced force of gravity causes it to fall in the glass of water. So let's take a look at your version of the tablecloth pull. You were supposed to have written what it was that happened in the tablecloth pull. What I would like to do right now is I would like to give you just a couple of minutes to read to the people at your table what it was that you wrote down. If for some reason you haven't written it down, then work together briefly to write an explanation. And then we're going to go over a suggested explanation that I have. So let's pause the video for 2 or 3 minutes while you discuss the explanations that you wrote. All right, so hopefully you are back and have had a chance to discuss what it was that you wrote to explain using scientific terms what happened in the tablecloth pole demonstration that you either saw in person or saw on video before vacation, depending on which class you're in. Let's take a look. This is my suggestion. It's not the only right answer by any stretch of the imagination, but here's how might write this one. So I might start an unbalanced force was applied to the tablecloth, which caused it to move. Okay. Uh, the friction between the tablecloth and the dishes, or instead of friction, that could be force also between the tablecloth and the dishes was not great. Was not a great enough force to overcome the, yes, this is that wonderful word, inertia. I can't spell. Okay. To overcome the inertia of the dishes. Therefore, the dishes did not move. And Miss Will is amazing. I hope you included that. Um, Feel free to pause the video at this point and copy that down, maybe underneath where you wrote or something, if you are unsure whether your explanation really included the scientific terms and included them correctly. All right. So now that we've kind of reviewed a little bit of what happened before our Thanksgiving break, let's continue with a little bit of review this morning. Let's take out the Newton's First Law of Motion review paper and let's take a look at these questions that we have here. Um, Again, I'm going to ask you to pause the video and spend about 3 to 5 minutes at your table working with the people at your table to answer these questions about Newton's first law. Go ahead and pause the video now. All right. So hopefully you've had a chance to go ahead and come up with some answers to each of these questions. You are certainly welcome to look back at your notes, so I hope you did that. Let's start with the first question. What does an object at rest need for it to move or for it to change its movement? Okay, well, it would need an unbalanced force or unbalanced forces to be applied to it. Okay. So in order for it to change its movement or in order for it to move, then an unbalanced force needs to be applied. What is number two? What is another name for Newton's first law of motion? Hopefully you had there. The law of inertia. Okay, law of inertia. So then what is inertia? Well, inertia, as we talked about before, is the tendency of an object to want to continue in whatever motion it's in. If it's at rest, it wants to stay at rest. If it is in motion, it wants to stay at that same speed and in a straight line. Um, Question number four, what causes a moving object to stop moving? Well, basically the same thing that you need to get an object that's at rest to start moving. You need unbalanced forces to be applied to it. How about number five? Would it be the more or the less mass an object has, the harder it is to change its movement? Well, hopefully you said the more mass an object has, the harder it is to change its movement. And on the last question, uh, would it be the more or less mass an object has, the easier it is to change its movement? Well, this time it would be the less mass an object has, the easier it is to change its movement. All right, if you would make sure that your first law of motion demos paper and this first law of motion review paper, make sure those both go into the current unit section of your binder. And we're going to start talking about the second law of motion in the next video.